my slides for that. So we added some part of that. Yeah. So we added some. No, I'm sure. Yeah. So, but because of the time limitation, I don't really want to explain my flight and also including my video because it's already including my previous part. So I'm gonna just show you. I already added that, and I will make some report for that. Okay, this is the second part. We already figured out 10 parts for that. So the left side is the correct one, and some of the editing part, some of the detail. So now, because of time limitation, I want to speak it out to Nicole.
And next, we'll continue introduce the second physics phenomenon is the Kessler syndrome. And let's watch the movie clip together first. Although the movie description is exaggerated, the disaster is shown in the plot is exactly Kessler syndrome, which is currently being closely watched by the astronomical community. Kessler syndrome is also known as the Kessler effect or collisional cascading. In a scenario described by the Kessler syndrome, space pollution has led to a significant amount of debris in orbits around Earth. The high density of objects increases the likelihood of collision, which can create the cascade effect, where each collision generates more space debris, further heightening the risk of additional collisions. Although there have been no accidents caused by the Kessler syndrome so far, a considerable amount of space debris has been observed in orbit. The risk associated with the Kessler syndrome has always existed. Currently, both NASA and the European Space Agency are actively monitoring this issue and discussing preventive measures.
Next, I want to talk.
give you homework. What happens to, say, equator space degree? Then what are the expected orbits of these degrees? Can you do it in the homework? Okay. Okay. Then Brian?
Yes. Can I start?
Please start.
Next, I want to talk about the Kepler's law of planetary motion. Kepler's law of planetary motion in astronomy and classical physics, laws describing the motions of the planets in the solar system. The first law states that every planet moves along an ellipse with a sun located at the focus on the ellipse. And the ellipse is defined as the set of all points such that the sum of the distance from each point to Foxy is a constant. The second law states that a planet sweeps out equal areas in equal time. That is, the area divided by time called the area velocity is constant. The time it takes a planet to move from position A to B, sweeping out area A1, is exactly the time taken to move from position C to D, sweeping area A2, and to move from E to F, sweeping out area A3. These areas are the same A1, equal to A2, equal to A3. Next, I want to talk about the third law. The square of the orbital period of a planet is proportional to the cubit of the semi-major axis of its orbit. The formula is expressed as cycle squared has a directly related to radius cubit. Using Newton's law of gravitation, this relation can be found in the case of a circular orbit by setting the centripetal force equal to the gravitation force. Peter, can I use the whiteboard?
Yeah.
We let the circle orbit. This, because of GM 4 pi squared is a constant, so it has a related has a directly related.
Okay. Can you?
Oh.
Okay, I'll give you a homework. You mentioned the interesting Kepler's law. So does the Halley comment follow the Kepler's law? You know Halley's comment? Oh. Does it follow Kepler's law? Mr. Moore? Okay. Yes or no? Yes or no? Yes, of course, yes, right. And he trained and everything for together. Okay, now calculate and don't calculate the area filled by Charlie's moment and then compare with other moments and then show the numbers that follow in your home. Okay, good. Then
Having explored these aspects, we arrive at our conclusion. In summary, our discussion of gravity has highlighted key scientific inaccuracies, particularly in how things happen in microgravity. The film's portrayal of space debris and the Kessler syndrome raised real concern about space pollution. While it captured the beauty of space exploration, gravity also underscored the need of accurate scientific representation.
After watching this movie, we found out there are lots of errors about physics. Perhaps it's for the plot. Perhaps it's for the plot or for aesthetic purpose, just as other members mentioned before. The thing that someone cried and the tears floated away in the space is beautiful. But in reality, the tears will stick around his eyes, which is funny. And about the things of a collision, if the collision of two debris is totally silent, there are no loud sound or grunt things, the film is going to be boring. In conclusion, when we watch a film, we could pay attention to any unrealistic elements. Perhaps we could find something interesting. And next part of our presentation is to discuss a difficult English word to pronounce in physics. We choose satellite. And the question is where to put the stress on syllables. It should be pronounced as satellite or satellite, like universe or universe. And let's watch a video. This video is made by Cambridge Dictionary.
Satellite. The World Cup was transmitted around the world by satellite.
So it should be pronounced as satellite. The stress is on sat.
the people who make mistakes about satellite, your friends know the satellite.
The most of the time, some of the time people
Pronounce.
so that's why he want to make a correction for that.
And let's play Kahoo.
Okay. So people please join. As usual, if you're number one, you get 1 point. So yeah. Who was the number one?
Number one is Anna. Oh, no. One. So you can join the class first.
Okay, it's not please join. Eric, did you join? Oh. Yeah. Oh, we named it number one.
cry in the space, why would your tears stick to your face? It's because, many people think it's because zero gravity. Just as other members introduced before, and let's watch a video to see what's going on actually in the space. Question 2, if a bomb exploded in the vacuum of space, what would you hear? Yes, Michelle.
But the answer was
Yes, question 1's answer is separate tension. And it's introduced in the part of
so that's the wrong answer.
Actually, the tension would be a drop on the make the tear drop. That actually not. It would be static tension to against that ground, so it will stick on the face.
What was the question?
Actually, the question
This one is not correct, isn't it?
no. The question, the question 1 is why the tears stick.
Yes, the surface tension is the same as in the Earth
Yeah.
and ocean.
maybe later we will mention about that, even in the report.
Okay. Okay, that's perfect.
And about question 1, we have a video to watch. If someone did this experiment in the space, he didn't cry, but he put some water around his eyes to see what will happen.
Okay, I have a question. Can you cry? Be fearful. Well, just cry. I can't cry in the man, but I'll go take some water. Take water. Look in my eyes, just get those back. Look at that. Let it stay over there. So, look as if I started crying, my eyes closed here. But you can see it just formed a ball in my eye. In fact, I put more water in. And so if you keep crying, you get bigger and bigger ball of water in your eye. Until eventually it crosses across the road, gets into the other eye, or evaporates and then it spreads over your cheek, or you got it out. Yeah, that's happening, all right.
As you can see, water gathered around his eyes. Therefore, if you cry in the space, your eyes will soak in water and your eyes will hurt. So you shouldn't cry in the space, or you have to prepare a towel.
But I mean, it stays there because there's no gravity. A lot of people answer no gravity. But I think that's also correct.
Yet we should correct the answer.
Because of gravity is good.
And about question 2, many people answered right because the sound should travel by medium, but there's no medium in the space. And question 3, if you were an astronaut, you could fly in the space without concern for fuel consumption because it's easy to get. Yes or no? The answer is absolutely no, because the weight of field should be calculated accurately. Yes. Question 4. What is Kessler syndrome? Just as Nicole introduced before, Kessler syndrome is also called the Kessler effect and collisional cascading. It describes increasing space debris could trigger a cascade of collisions and affect the space activities in the future. And the other three options are Kepler's first law, just Brian introduced before, and second is Doppler effect, and the third is reaction force.
Question 5. What direction do most satellites move in? Question 6. What would happen to the astronaut who is nudged by the others in the space? Question 7. An astronaut easily gets across the two space stations by a simple skywalk. The last question. Which law can be used to explain astronauts won't drift unnaturally without external force?
Online? Is there any comments? Are you happy? Okay, now you guys, can you explain the difficult one? Question?
Okay, for introducing, because most of the questions is related my previous slide. So I will. Let me see. Yeah.
Please.
Yes, why not? And explain why it's doing
Because we mentioned that so two astronauts in zero gravity would remain and together would stay. So it would be the same of the push. If small push, it would be the small tension and small separations. So it's no push, it would be no movement. So why wouldn't stay drift away in the real world? So because it's no external force in space, so it would stay together and move apart only as a result of their move. So it will explain. That's why they will stay in the place. So, any other questions? Okay. So from that, we can see the because last video already showed about one day did some explosion. Their way is from east to west. Actually, we can see this picture. So we can see here. It would be like this one, so it would be west to east.
why is that? Why cannot go the other way around?
The other way.
From east to
Yeah.
why North Korea is giving missile to Japan but not to China? You know the North Korea
Oh yeah.
always send missile to Japan, but they never send it to China. Why is that? It's not because they're afraid of China.
Yeah.
The Earth is rotating.
Yeah, rotating. Yeah.
So it's the same thing. The satellite will be easier to launch from west to
West to east.
Okay.
That's
good.
what it is.
Okay, very good question. Thank you very much. Very good presentation. Any questions? Yeah, if not,